Welcome to the deep dive. If you're looking to, really get to grips with something foundational, you're in the right place.
Definitely.
Today, we're diving into the work of Jabir ibn Hayyan, maybe better known in the West as Gibber.
Right. Born around 721 AD in Tos, Persia, that's modern Iran, during the Abbasid Caliphate. A pivotal figure.
Absolutely. And our mission here is really to understand why he's often called the father of chemistry. What was his impact?
Exactly. We're looking at an overview of his life and his contributions, trying to unpack that legacy. It's pretty fascinating stuff.
Okay, so alchemy. Many people think of, magic maybe, trying to turn lead into gold, but Jabir changed that perception.
He really did. The key thing, and our source highlights this, is that he shifted alchemy, moved it away from just mystical ideas and towards an actual experimental science.
Experimental how? What did that look like back then?
Well, think systematic experimentation. He wasn't just theorizing. He was doing, performing tests, really carefully documenting everything he did, observing the outcomes.
Which sounds basic now, but back then...
Exactly. It was revolutionary. Before Jabir, alchemy often involved, secret recipes, maybe mystical interpretations. He pushed for repeatable experiments, careful measurements. It was a huge leap.
So less mystery, more method.
Precisely. Doing and recording, not just thinking and hiding the process.
And this wasn't just theory, right? He developed actual lab techniques.
Oh, absolutely. Things we still rely on heavily today. The source mentions distillation separating liquids.
Like making spirits or purifying water.
Yeah, based on different boiling points. And crystallization, forming pure solid crystals. Also sublimation, evaporation, filtration.
Separating solids from liquids, basically.
Right. These aren't just historical curiosities. They are fundamental processes in, almost every modern chemical lab. Think pharmaceuticals, manufacturing. They all use refinements of these techniques.
It's incredible they go back that far. So
Yeah.
This new rigorous approach, what did it allow him to actually discover? What came out of it?
Well, that's the payoff, isn't it? This method enabled him and his school to isolate and describe substances properly for perhaps the first time.
Like what, for example?
Think major acids, sulfuric acid, nitric acid, hydrochloric acid. These are cornerstones of modern chemistry.
And weren't really defined before him.
Not clearly, no. And he even formulated aqua regia, the mixture that can dissolve gold. That was a big deal. He gave chemistry the tools to identify and work with these essential building blocks.
The source also touches on metals, metallurgy. How does that fit in?
Yeah, that was a practical application of his chemistry. He worked on purifying metals, creating alloys, understanding materials better.
And what about the classic alchemical goals, the elixir of life, the philosopher's stone? Was he still chasing those?
Well, yes, that was definitely part of the context. Those big, maybe fantastical goals were often the motivation behind the experiments for many alchemists, including him.
So even if the goal wasn't quite achievable as imagined.
Right, the process of trying to achieve it led to immense practical investigation and real discoveries. It pushed the science forward,
And the amount he wrote, or at least attributed to his school, it's staggering.
It really is. Over 3,000 works, apparently, including major texts like the Kitab al-Kimya, the Book of Chemistry, and the Kitab al-Sabin, Book of 70.
Wow, that's prolific.
And crucially, this body of work had a massive influence, especially when it reached Europe.
Through his Latinized name, Geber.
Exactly. Geber became hugely influential. For centuries, European chemists and scholars in the Middle Ages, the Renaissance, they were studying his translated works, building their own understanding right on top of his foundations.
So if you trace the roots of modern chemistry, a lot of threads lead back to Jabir.
You really can't overstate it. Modern chemistry owes a huge debt to his insistence on empirical methods, experimentation, and just the sheer amount of practical knowledge he helped generate is a fundamental shift.
Okay, so let's quickly sum up the key takeaways for everyone listening.
Jabir's big contribution was emphasizing experimentation, developing core chemical processes we still use, and identifying fundamental substances like major acids. Truly revolutionary.
Absolutely. Couldn't have put it better.
And that leaves us with a final thought to ponder.
Go on.
Consider how that systematic approach Jabir pioneered, observing, then experimenting, then recording, how it continues to shape not just chemistry, but so many fields today.
That's a great point. What other areas of modern science, or even like social sciences or humanities, still rely on those foundational principles of systematic inquiry he helped establish all those centuries ago? Something to think about.